Yeah, acids are proton donors. Good. That's a good way to think of it. Your book worded it a little bit differently. And I kind of like this wording better because it says, when a molecule is dissolved in water, certain molecules ionize. What's it mean to ionize? Not to mix and not just to have a charge. When I kind of. Ionize is a verb. I should say it that way. What does it mean to ionize? To become an ion, right? So when we say it ionizes, what did you say, Jake? Something like that? Okay, so ionize means to become an ion, right? To have a charge. So when things dissolve in water, that means the molecule splits apart and forms two distinct ions. One of those ions being H+. Right? So when a certain compound is dissolved in water and it forms two different molecules, one of which is H+, that means it's considered an acid. Or like Drew called it, or I called it last year, a proton donor. If it's able to donate a proton to something else, it's an acid. Okay? So when we talk about protons, a proton donor, this is a proton, right? H+, the H+ ion is a proton. Because if we think about hydrogen by itself, hydrogen has one proton, one electron, 0 neutrons, right? Basic hydrogen. Isotope 1 of hydrogen looks like that. But if we have H+, that means we don't even have an electron. Which means when I say it's a proton donor, it's donating H+.
Wait.
Right, it gets rid of H+, and someone else can take it. A base can take it. Uh-huh.
And when it's gaining?
When it's a proton acceptor, that's called a base. Right? You have acids and bases. So when it's a proton acceptor, that's called a base. We're not going to get into that as much because naming bases is just like naming ionic compounds. Bases usually contain hydroxide. So naming bases is just like potassium hydroxide, calcium hydroxide, same thing. Okay? But naming acids we do a little bit differently. Questions about what an acid is in general. Tell me, what does a compound have to be considered an acid?
Positive.
Now it has to have what element?
Hydrogen.
Has to have hydrogen. Okay? Because it has to be able to donate a hydrogen to something else. Acids usually have hydrogens in the front. Right? These are both examples of acids. So they usually have hydrogens in the front of the compound. That's how you kind of know it's an acid right off the beginning. Okay? They can get rid of these two hydrogens and donate them to something else that makes them an acid. Okay? All right, so how do we name them? I'm going to give you the 4 levels of polyatomic ions and then the acids that go with them. Okay? Maybe. There we go. All right, these are the 3 levels of ions we're familiar with. I added in one more. Okay? I added in one more. And I'm going to pull up the example for chlorate. I can't spell. Did we talk in here about how I think I'm a good smeller? And then apparently I'm not a good
smeller. Or smeller?
I said speller.
I thought you just said smeller.
I'm a fantastic smeller, too. Okay, so if we started with chlorate, my bad. Ooh, chlorate. That means we would have chloric acid. Okay, if we started with chlorite, we would have chlorous acid. If we started with chloride, that's just Cl by itself, it would be called hydrochloric acid. Okay? So let's look at how do we put those compounds together. Right? Chloric acid has to be chlorate, ClO3 minus 1, with how many hydrogens? How many hydrogens do we need to balance that? Just one, right? Because chlorate's charge is -1. That means my acid would just be HClO3. And for chlorite, I take chlorite plus hydrogen, HClO2. And for hydrochloric acid, I would take HCl. Agreed? Do you see where those came from? Okay? And then if we level up one with perchloric acid, we would take perchlorate, which is HClO4 -1, and still pair it with one hydrogen, so HClO4. Okay? I didn't put any of the polyatomic ions on your memorization, because if we know the 8, we should know that per just means one above, right? One extra. All right, so let's do some practice with our acid naming. That's it. That's the rules for acid naming. So you're going to have to write those rules down. I'm not going to give them to you on the test like I did previously. And you're going to have those memorized. Ammonium and ammonia are both positive ions, so they wouldn't ever form an acid. Good question, though. Give me the name for this H3PO3. Let me get myself a little bit adjusted here. H3PO3. Okay, so what's my first step in going from compound to written name here? What do I have to figure out? What polyatomic ion did it come from? Phosphite. And so the name of my acid would be?
Phosphorus.
Good. Yeah, this one's tough. We actually keep the R in there. Phosphorus acid or phosphorus acid, which is so silly because that's just its actual name. Right? It's just silly. I don't know why you keep the R in on some and not on others. It's just kind of a what do you think sounds better type of thing. I'm sure there's an actual rule, but I don't know what the rule is, and it has so many exceptions that it's not really worth learning anyway. But phosphorus, we would keep. Sulfurous, we would keep the R. I don't really have a rule for that. But I wouldn't count you off if you would have just put phosphorus acid, even though it's not quite right. Okay, give me the formula for carbonic acid. Yeah, Jackson, what do you got? H3CO2. H2CO3. Which one is it? This one. So this is why. Did you know carbonate is CO3 minus 2, or did you get those two mixed up?
I got it mixed up.
You just got these two mixed up? I just want to make sure we weren't switching something extra. This is carbonate. Here's hydrogen. So we know we need to have 2 hydrogens to balance that out.
Oh yeah, you can't get rid of the...
We don't ever adjust that subscript.
That's what I did, yeah.
Okay? We don't ever adjust that subscript. So our correct formula would be H2CO3. We don't ever reduce acids because hydrogen's a 1. So you would never need to reduce anything. Right? There's never an instance where you would overshoot it, if that makes sense. Okay? Give me the formula for hydrolyotic acid. Hydrolyotic acid. Which, so if you're not sure how to start, think about, okay, hydro and ic means it has to come from just the root by itself. So what's the root form here? Iodide. So you have to find iodide on your periodic table. It's an IDE. That means it's not a polyatomic ion, it's just an ion. So iodide is I minus 1. And we know it has to go with hydrogen.
Plus one.
H. It's just
Hi.
HI.
It's just high.
I wanted to put that too.
I'm sure some of you come up with like a clever, like cutesy joke to go with that one, but not so much me. Okay? What'd you say? It's the end of the day. It's been a day. All right. Jackson, does that make sense where that came from?
Yeah.
This, we look for the root, and we know it's got to be just the ion itself, and then we pair the ion with however many hydrogens we need to balance it, and that's what we get.
I thought it was a polyatomic.
Okay.
That's what I did.
Hydro, the fact that it has hydro on it means it's going to be just one of these by itself, just the ion by itself. Okay? Give me the written name for these next couple. Give me the written name for those two. Hydrosulfuric acid. Good. All right, Malia, what'd you have on the second one? Bromic. Good. So bromate was not one we had to memorize, but we could find it here on the table. Good. Okay, let's go now. Name to formula. Last couple here. Name to formula. Roy, what'd you have for the first one? Good. Good. Do you see how it's, I guess on yours it's written differently. Acetate is sometimes written like this. CH3COO minus. It's still the same. That's 2 carbons, 3 hydrogens, 2 oxygens. Right? It's the same thing. The only reason it's written this way, it has to do with its structure. This is the way that oxygen, that's the way its structure looks. So here's CH3COO. Right? That's the reason it's written that way. I don't know why it's the only one that is written 2 different ways. I don't make the rules, but that's why it's done. That's why it does that. Okay. All right, nitrous acid. Sam, what'd you have?
H2. NO2.
Okay, yes or no?
Yeah.
What's the charge for nitrite? NO2 is -1, so that means we just need H NO2. Okay? So HNO2 is our acid for nitrous, right? The actual polyatomic ion is NO2 -1. Okay?
And you have to balance it.
And you have to balance it. If you want to, you have to look at how many hydrogens do I need to balance that out. And they just fit together 1 to 1, so that's why you got that one. Okay? How we feel about acid naming? Fine? We're going to do now mixed. Ionic, covalent, and acid. So you got to figure out what type of compound is it first, and then how do I name it correctly? All right. Do we need to review principles of each one, or do we feel okay just jumping in? Okay, love it. Okay, here we go. I'm going to give you 3 here. You give me the opposite, right? So first one, give me the name. Second one, give me the formula. Third one, give me the name. It should be mercury chloride. But based on this formula, what version of mercury should it be? It should be +1. And I didn't realize that that wasn't listed as a possible charge for mercury.
It is, there is. It is. Yeah, it
Just
just,
has a +2 with it.
It both have +2, so that's why I was confused.
Oh yeah, okay, I see what you're saying. All right.
So like that with the what you gave us, it would have to be
Yeah, you're right.
GCl.
Okay, let's forget that one. I don't know why. Yeah, I would have named it just based on this 8 mercury 1 chloride, but I didn't realize it made it funny on here saying Hg2, and then it has a 2+, so forget that one. Sorry about that. Just when in doubt, name it exactly like it should be up here. I didn't pay attention to what was on your sheet, and that was my fault. Sorry. I feel like if the Roman numeral is 1, I don't know why there's a +2. And I don't know why there's a 2 there anyway, so that's my bad. Are we ready to look at the next 2?
no. I took this entire time on that one.
Okay, all right. Go ahead. Yeah. Jackson, what'd you have for number 2?
H3PO3.
Nice. Nailed it. H3PO3.
And then
Okay. Manju, what'd you have on the 3rd one? What'd you say? Okay, that's all right. Laurie, what'd you have on this one? Dinitrogen trioxide. Good. So a couple things with covalent naming. Regular ending on the first one. When does the first one get a prefix? If there's more than one. Second one always ends in IDE and always has a prefix. Do we have to do any crisscrossing with covalent compounds? None. No connection with the charges, no crisscrossing, nothing like that. Okay. Let's try this one. Give me the written name. It is. It's a 2, sorry. Uh-huh. Hydrosulfuric
how do you
acid.
You are.
It comes from sulfide, so we need to do hydrosulfuric acid. Okay. First one. Jared, what'd you have? Okay. Really, what'd you? Okay, Jake, what'd you have? Manganese 4. Good. Sulfide. Hopefully you didn't put magnesium.
I like manganese.
Manganese. Manganese 4. Do you want to go over why it's 4? How many of you put 2? Okay, let's go over why it's 4.
I just added up.
MnS2. Okay, so let's look at why is it 4? If we reverse, do you like the crisscross method or you want to not do crisscross method?
I do that.
Honestly, when you taught the crisscross method, that's when I started getting the crisscross.
Okay, all right. So let's not think about crisscross. What's sulfide's normal charge?
-2.
-2. That means I've got a -4. That means this has to be +4. Right?
Same. No,
You goof.
at least you didn't. At least you didn't put cyanide for arsenic.